All right, so why don't we call the meeting to order? This is the task force to study hydrogen power. This is Brian Garcia. I am here in Torrington, Connecticut at the fuel cell energy manufacturing plant. I have to say it's been a while since I've been here. I'm very excited to see all the new expansions and looking forward to hearing more from the fuel cell energy team about the manufacturing that's going on here. So I wanted to thank Tony and his team for hosting us here this morning. We will hear some remarks from Tony in just a second. Why don't we go to the next slide? Let me provide an overview of the agenda here today. So we're going to hear from Tony, as I was mentioning. We're going to work through the meeting minutes. It looked like you all had a great meeting last time. So we will review and approve those meeting minutes of September 13th. We do have a few new task force members. I will track them to see if we can have them do some introductions when we get to that third agenda item. Then we're going to hear from our friends at the Sandia National Lab on hydrogen safety. And then we've got our friend Adrian Ferrari-Well on the line here from the Bridgeport Regional Energy Partnership, who is going to have a conversation with Aaron. And then we're going to hear a working group updates, specifically from a couple of working groups, where we're going to delve in a little bit deeper. And then we're going to wrap up with public comments. And for those of us who are here in Torrington, we're going to get a tour of fuel cell energy. So with that, why don't I turn it over to Tony Leo of Fuel Cell Energy. And we have a few slides that Tony has sent. And we will have Tony walk us through. Tony, thank you again for hosting us here. Very welcome. My pleasure.
Sarah, are you going to pull the slides up? Go. Okay. All right. Yeah. So this is just a very brief introduction to fuel cell energy for those of you who may not be familiar with the company. Next slide, please. So the first thing we'd like to talk about is our purpose, what we're trying to do, which is enable a world empowered by clean energy. And we do two things. We decarbonize power, either by producing low or zero carbon power, or by capturing CO2 from power generation. And we supply hydrogen. In some cases, we are looking at storing that hydrogen as energy storage technology. Those are basically the two things we're doing: decarbonizing power and producing hydrogen. Next slide, please. So a little bit about Fuel Cell. We're a Connecticut-based company. We've been here since 1969. In Danbury, Connecticut, we opened our first factory here in Torrington in the late 1990s, and then opened a second factory here in Torrington in the early 2000s. Just about 400, approaching 500 employees at the moment. We have 225 plus megawatts of power generation systems installed around the world. And you can see in the upper right, we have a mix of customers, from commercial industrial customers who are making their own power behind the meter and heat, as well as utility customers for front of the meter applications, and development partners like ExxonMobil that are helping us with some of our technologies. Next slide, please. So these are our two Connecticut facilities. Our headquarters are in Danbury, Connecticut, and our manufacturing is right here in Torrington, Connecticut. As I said, there are about 167,000 square feet of manufacturing capacity. We do have some other facilities around the world. We have a final assembly and service facility just outside of Munich in Germany that services our carbonate fleet in Europe. And we have a development and manufacturing facility in Calgary, Alberta, Canada. It's focused on solid oxide cell and stack development, in addition to the solid oxide development we do here as well in Danbury. Next slide, please. So we have these two technologies, carbonate and solid oxide. They both have a lot in common. They're both high temperature fuel cell systems. They're both able to do combined heat and power, very high efficiency. Natural gas, biogas, hydrogen blends. Solid oxide can run on pure hydrogen. Carbonate needs some CO2 for its electrochemistry to work, so it can work with hydrogen blends. Both of these technologies are capable of capturing their own CO2. When you react a fuel in a fuel cell, produce CO2 that is more easily extracted than most power generation systems. So they could both capture their own CO2 to avoid carbon emissions. Carbonate has this unique ability to capture CO2 from an external source just because of its unique electrochemistry. Both of these systems make hydrogen from fuel inside the stacks, so that hydrogen can be exported as a hydrogen stream, if you will, from the system. I'll talk a little bit about one of our platforms that is doing that. And solid oxide is capable of very high efficiency electrolysis hydrogen production, running it backwards, if you will, making hydrogen from power instead of making power from fuel. Carbonate can do that as well, but it has to be combined with. Next slide, please.
Next slide.
Are folks seeing my slides advancing?
We're on slide 5 still.
Lily, I can slide 6.
Yeah, I can see slide 6.
Maybe a delay in the room.
I know what's on slide 6. So slide 6 is a example of what our carbonate platforms look like. The fellow on the left is holding a single carbonate fuel cell. The stack behind him is a 400 cell stack, and that's the core of our system. 4 of those go into our 1.4 megawatt module. That's what we make here in Torrington. So one of those modules goes into a 1.4 megawatt system. 2 of them go into a 2.8, and bigger systems are made by putting multiples of those units together. Next slide, please. So this is an interesting hydrogen, since this is the Connecticut Hydrogen Task Force. We are introducing a new version of our carbonate system that, as I said, can export hydrogen. This is the first commercial scale. We've done a few demonstration projects with this technology. This is a project we're doing for Toyota at Long Beach, California, at the Port of Long Beach, where they import their Mirai fuel cell vehicles, and where they're also doing a hydrogen truck demonstration. So they have a good on-site demand for hydrogen. So this system will provide 2.3 megawatts of power. Some of that will go to Toyota to satisfy all their needs, but they pay, the local utility will pay. It'll produce 1,200 kilograms a day of hydrogen. And it also does something that no other hydrogen production system does. It produces water. It produces 1,400 gallons a day of water. And it just so happens that Toyota uses a lot of water at the port because when their cars come in, they have to be washed. And they're in a drought zone. So this is an example of a hydrogen production technology that's really unique. It produces hydrogen. And it's really applicable in an area where you have high power costs because it's producing power, so that would be a revenue stream, and concerns about water consumption because electrolysis does consume water. Next slide, please. And just the other trick we do with carbonate is the various carbon capture applications. One we call carbon separation, where we capture the CO2 from the unit as pure CO2 to be used by an industrial or food and beverage source, so it's not emitted as an emission. And that's commercially available today as a standard option. And the other that's in development is carbon capture from an external source, where we take the exhaust from the power plant or boilers and send it into the fuel cell air intake and capture CO2 from that exhaust. So that's under development, but the carbon separation is commercially available today. Next slide, please. And lastly, a little bit of our solid oxide technology. We're developing a common platform that can support power generation applications, hydrogen production through electrolysis, energy storage through hydrogen-based energy storage. So on the left there is a single solid oxide stack. It's about 1.5 feet high. It can produce 7 kilowatts of DC power, or if you give it 36 kilowatts of DC power steam, it can produce 25 kilograms a day of hydrogen. Very, very versatile technology. It can flip back and forth between fuel cell mode an electrolysis mode, and if you store the hydrogen, send it back to the fuel cell. In the fuel cell mode, that's the energy storage application. So it's uniquely, what the unique thing about our solid oxide electrolysis is very high efficiency compared to conventional electrolysis. So we're doing our first demonstrations with this technology right now, and so more to come on this technology. I think that's it.
Excellent. Thank you, Tony. Thank you for that overview. Wow, lots of exciting developments going on here at Fuel Cell Energy, and we're looking forward to doing the walkthrough later and learning a little bit more. Thank you again for hosting us. You know, we've been doing these hosting events. You know, a few of us have come here or there, but wanted to thank Ur and you know, President Merrick at UConn for hosting us at the Technologies Building, the Innovation Building there. Kathy, thank you for hosting the crew last month in Wallingford there at Nell Hydrogen, and thank you, Tony, for you and the crew today here in Torrington. I really want to like show off what's happening here in Connecticut, because not a lot of people see that a lot is happening here in this small state, but it's really exciting to see that. All right, so why don't we get to the approval of the meeting minutes for the September 13th meeting. We've provided a draft of those meeting minutes. I was able to review those this morning and noticed that quite a bit of work has been done, especially on the working groups and the charters. So looking forward to hearing more about that. But does anyone have any questions, comments, or someone want to move the approval of those meeting minutes?
Oh, you gotta sit down. Sit down. There you go.
I'll move it.
Second.
Great. We captured the second. Any questions, comments? All right, all in favor say aye.
Aye.
Aye. Aye.
Opposed? Any abstentions? All right, great. Good set of meeting minutes. Thank you, Strategy team, for those very, very comprehensive notes. Okay, so we are. Yeah.
Brian, can you just let us know who nominated and seconded that? I think it happened in the room. We didn't catch it.
Sarah, it was me, DeGanto,
Thank you.
who nominated.
Eric, Annis, Deep tried nominating, but someone else might have too. It was a lot of voices.
Okay, great. Thank you.
All right, let's keep going. All right, so, you know, I feel like we've been doing this month to month, introducing new members to the task force. We're almost there. We wanted to go around the room and introduce our three new task force members who were appointed, by Senator Looney. Let me just introduce their names and we'll have them go around and say a few things about themselves. We've got Enrique Bosch, Sridhar Kanuri, and Shannon Long. And I'm going to ask each of them, why don't we start with Enrique to introduce themselves to the task force.
So thank you, Brian. Thanks for having me here. Enrique Bosch, I'm the head of innovation at Avangrid. Avangrid is the utility. We serve around 7 million people in the area in the Northeast. And we are the third largest renewable energy operator here in the US. Joined the company like 6 months ago, so pretty excited to be here and make a contribution. My background is 3 years in the energy sector, working divisions and optimization of growth.
Excellent. Welcome aboard. We can go to the next slide. Let's go to Sridhar. Sridhar, are you there? Sridhar is from Hyaxium, which is the new name for Doosan Fuel Cells, and he is a Connecticut hydrogen manufacturer representative. Okay, let's go to Shannon. I saw you, Shannon. Maybe on mute.
No, sorry, I'm here. I'm coming through twice. I was trying to figure out how to turn on my video, which was not working on the browser. So sorry about that. It doesn't seem to be working. But thank you. It is great to be joining the Hydrogen Task Force. As you mentioned, I am the Connecticut State Director for Conservation Law Foundation, which is a regional environmental advocacy organization. And I'm also an attorney. So I'm very excited to be participating, and thank you for the warm welcome.
Thank you, Shannon, and thank you for being involved along the way and being, continuing to push us to fill these task force slots. Welcome aboard. We do have 2 slots currently open. Senator Kelly has an environmental NGO or a renewable energy advocate slot open, and someone from the Connecticut Hydrogen Fuel Cell Coalition. So, folks have recommendations, send them along. We'll continue to send to the senator and his staff those recommendations to see if we can get those appointees in place. Why don't we go to the next slide? Thank you to all the ex officio members and their support teams, Deep, Pura, UConn. So thank you for all the support teams there for the commissioner, the chair. Congratulations, Barbara, to the President Radenka Merrick, now becoming president of UConn. That was very, very exciting. So thank you for your support of President Merrick on the task force. I see Joel online. Good morning, Joel. So that's where we are on the task force. We're in pretty good shape. We'll work hard to see if we can secure those final 2 slots this coming month. Okay, let's go to the next slide. Just to give a sense for where we are on the task force meetings themselves. We've got November, December, January. January is coming up upon us pretty quickly. That's when we hope to get everything assembled and provided to the Energy and Technology Committee. I think the date is the 15th of January. So we've tried to lay out the November, December, and January task force meeting agendas in general. We're going to start to really dig into the working group findings and recommendations next month. We're going to hear about the progress some of those working groups are making today. It's significant. We're going to continue to dive into more information around hydrogen. So we've got another federal lab with us that will dig in there and provide us some education a little bit more advanced than where we're steadily improving all of our knowledge on hydrogen and fuel cells. We may have a speaker on just transition, thinking about the importance of the workforce at that meeting as well. And then looking at December, and thank you, Weezy, I see you on the line. Thank you for hosting us at Dominion. So we're looking to head to the southeast side of the state from up here in the northwest side of the state to visit Dominion. So thank you for hosting us there. Then in December, really that's where we're going to start putting the pen to paper on the findings and recommendations. We will most likely continue the conversation we've been initiating around environmental justice, just transition, and thank you to Hyaxium for being willing to host us to have a tour of your facility there in South Windsor. And then hopefully by January, as we come back from the holiday, we'll have all the pieces assembled and be ready for the report submission as the start of the legislative session begins, specifically with the Energy and Technology Committee. I think Aaron's going to give us a high-level overview of some of the proposed components of that report. So put your thinking caps on and get ready for that, as Aaron's going to provide an overview here in a second. Let's see, I think that is it. Aaron, anything else before I turn it over to you?
No, Brian, that looks good. Thank you so much.
All right, so why don't I turn it over to you, Aaron? You all have been incredible keeping things moving at the working group and task force level, and I'll turn it over to you to introduce our Sandia National Lab speaker today.
Thanks, Brian. So we are very excited to have Kristen Hertz with us today. Kristen is a hydrogen program manager at Sandia National Lab, and she'll be discussing hydrogen safety and some of the research that Sandia is conducting in this space. So without further ado, Kristen, I'll go ahead and turn things over to you. We'll run slides. You can just let us know when you want to advance to the next slide.
Thank you. Good morning. As Aaron just said, I'm Kristen Hertz, and I'm the Hydrogen Program Manager for Sandia. I am not the technical expert. I am really the manager who tries to oversee and understand the breadth of work that we're doing at Sandia. So my talk is focusing on work not done by me, but the staff at California and the New Mexico sites. We are in both locations and in conjunction with partners at our other labs, industry, and universities. And since right now is such a exciting time in hydrogen, I thought I'd take a moment to state the role of an FFRDC, which I'm sure most of you are very familiar with, but that's the federally funded research and development centers. But we generally partner on technical topics with industry and work with the universities and our other national labs to perform research and development. And one of the main things is we cannot compete with industry, and we do attempt to make our work as accessible to everyone as possible. In the hydrogen space, DOE's Hydrogen Fuel Cell and Technology Office, HFTO, does make a specific effort to partner with our work with industry so that the science we do has as direct an impact as possible with industry. And so it is pretty exciting because our work then does help industry get their technologies out into the market, yet we get to concentrate on cutting edge science and basic research. So to us, this is a great partnership. Next slide, please. So I'm discussing the work at Sandia to hopefully bring a bit of understanding about the science that goes into understanding the various aspects that do need to help bring hydrogen into the marketplace. Sandia is one of the lead labs on safety, but I do want to just make clear the national labs all work together, and this is a big effort that is done, as I mentioned, with industry and universities as well. And we all know that hydrogen has been around a long time as a chemical and in various industries, but as it transitions to being more ubiquitous, there are standards that may need to be clarified and some basic understanding of the behavior of hydrogen and the materials it interacts with that are important to continue to develop. So there are two areas I will focus on. The first is the research that we do for safety codes and standards. That includes materials compatibility, safety and risk, and we did a study on the regulatory map, so the agencies involved in regulation. Then we will talk about what we do to facilitate end uses with examples from rail, light duty, and maritime. Next slide. So don't want to go into detail with this slide, but I just want to mention that Sandia has a rich history of science-based engineering and systems engineering with respect to hydrogen isotopes. We are one of the National Nuclear Security Administration's laboratories, and so of course our hydrogen work was started with our support of the nuclear deterrence mission. So it's been around since the 50s, 60s, so we have a long history in this area. The work is focused on understanding materials characteristics, which is shown in the bottom left, and provides a good basis for our energy programs. I think the statement at the top of this slide is the only thing I really want to go into detail with, but it accurately describes our emphasis. So we provide deep quantitative understanding and a scientific basis for materials. And this spans the extent of the hydrogen economy, so production, delivery, storage, conversion, and utilization, and safety, which is risk analysis and the creation of risk-informed standards, which clearly is very consistent with our nuclear deterrence mission, which is, always have our nuclear weapons work when we want them and never when we don't. So that's very, risk-informed. So the only other thing I'd point out on this slide is I think most of you also know that HFTO has always funded these large consortia. So on the slide, all these little symbols are the consortium HFTO funds that we are a part of: hydrogen in production, high mark in hydrogen, solid hydrogen storage, high blend, which is the blending of hydrogen into natural gas pipelines, and HMAT which is just general materials work, and then high RAM plus is this code I will talk about in a little bit more detail. So next slide, please. So it is well known that hydrogen affects the mechanical properties of metals and other materials. To understand these effects, the relationship between the material, the environment, and the stresses, both static and mechanical, that are placed on the material throughout its lifetime need to be understood. So the ultimate goal of this understanding is to determine how do we reduce the risk of failure in these materials. So next slide, please. To understand how the materials fatigue and fraction, we need to test them in hydrogen environments. The environments need to be consistent with the lifetime and pressure cycles for components needed to store and move hydrogen. To perform this work, we rely on our extensive facilities and capabilities. So we have a well-known hydrogen effects in materials laboratory that houses several systems, which are shown on the left, where we can work with materials in gaseous hydrogen environments at various pressures and temperatures. We also conduct tests that cycle the samples shown in that blue kind of box through various mechanical loads to see how fractures develop in the material. Then we have tools that allow us to probe the material. So those are the ones on the right mostly, to determine how the hydrogen affected its structure at the surface and within the bulk material at the atomic scale. Although I didn't show it here, to get a fundamental understanding of what is happening to the material, we need computational expertise as well. So our modeling capabilities continue to enhance our ability to understand the fundamental hydrogen material interactions, and are even assisting us with predicting which materials may have the best characteristics for the intended use. So we continue to push on our experimental capabilities to provide the necessary data for input into the models that can then validate our results. Next slide, please. So that I just wanted to go through to kind of establish and give you a glimpse of the type of research that we do. And so now I'll start discussing how that impacts the work, how all of this work impacts the hydrogen economy. So this first example I want to give is an example of ASME code that our work helped define. The lifetime of pressure vessels that are used to store hydrogen was based on the number of fill cycles that they had. And this was independent of the pressure difference that the cycle was undergoing. It was just a strict count of cycles. So even if you just like your iPhone battery, if it would be the number of charges, whether or not you went halfway down or all the way down. Now the code is based on the fatigue crack growth rate design curves that were measured at Sandia and recently accepted into the code. So fatigue crack growth tests measure the rate at which a crack grows when a force is applied to it. So that force would be the pressure in the vessel. And so now you can use this design curve to extend the life of your vessel. So the design curves we measured were for steels used in the high pressure hydrogen storage vessels commonly installed at hydrogen refueling stations. And these enable approximately 3 times longer design life of typical hydrogen storage vessels compared to the previous design basis. And this can reduce cost by enabling longer pressure vessel life, removes the need for expensive and challenging materials testing, and provides harmonization of the design curves. Another area that I mentioned in that overview slide is that another area that's of interest with respect to materials work is the blending of hydrogen into current natural gas pipelines as a way of delivering hydrogen. HFTO did fund a large consortium called HyBlend to do some work in this area. And Sandia has worked on both metal and polymer-based pipelines. Industry has sent us a bunch of samples of the legacy pipelines and materials that are out in the field already. And so we've been working with them to test and understand these materials. So a lot of knowledge has been gained in that area. Next slide, please. So moving a little bit to a new area, but not only are we interested in how hydrogen affects the materials it interacts with, we are interested in how the hydrogen behaves when it is released in an unplanned way. So again, we want to apply scientific basics to this risk. And this slide shows how we process, shows the process on how we assess that risk. So the left panel is understanding the behavior, so behavior R&D. This focuses on hydrogen, how hydrogen behaves. For example, if there's a leak in a pipe or a rupture, how does the hydrogen, what does it look like when it's released? How does the plume expand? Does it ignite? All of those. So what are the conditions needed and what does it look like when it is released? In the middle, we have the risk R&D. This focuses more on the reliability of the equipment. So how often do components fail? What is the consequence of that failure, et cetera? So when you're designing a system, all components in that system need to be considered in the quantitative risk assessment. So this can fold all that information in there. So on the right, we combine both the behavior and the risk assessment to assess a scenario, such as a refueling station or a hydrogen vehicle accident in a tunnel. So to do this work, Sandia developed and maintains HYRAM Plus, which is it stands for Hydrogen Plus Other Alternative Fuels Risk Assessment Models. And this is a software toolkit that integrates data and methods relevant to assessing the safety in the use, delivery, and storage infrastructure of hydrogen and other alternative fuels. Right now, it's both methane and propane that you can use as well. And the calculation incorporates generic probabilistics for equipment failures for different components for both compressed gaseous and liquefied fuels, and probabilistic models for effective heat flux and overpressure on humans and structures. So this is a code that we have made freely available to anybody who wants to use it. Next slide. So with that code that we developed, we need the data to support it and go into it. And as we did with the materials characteristics, we also plan and conduct experiments and compare to the models to validate our results. So, but this time with respect to hydrogen behavior. This approach is important because we need to trust that our models can be used to test a variety of scenarios. So when assessing risk, we want to think of all the possible outcomes that could occur in an event, in a system with all the different components. So running experiments for all of the scenarios is prohibitive. So we really need to be able to combine it with modeling and come to a thorough understanding of the behavior of hydrogen releases in the variety of possible failures in the system. So although most of our experiments are done in a very controlled environment in the lab, this slide shows experiments that release gaseous hydrogen outside to measure the size and direction of the plume with and without wind and other environmental factors. So this was a large experiment done in collaboration with Lawrence Livermore National Labs. They had a nice system set up that released hydrogen gas in a plume raised up pretty like 30 feet in the air so that it would be able to move freely and we could understand how it behaved. So next slide, please. And similarly, we also want to understand the conditions that allow for hydrogen ignition and how the jet flame behaves. So not just how the gaseous plume would go, but if it ignites, what happens as well. And to do this, we use a laser to heat the hydrogen plume, and that's nice because we can focus that laser on various spots within the gas plume and try to heat that specific area up and ignite it and see how then the hydrogen flame behaves. So the results from these experiments can validate our models. Again, you're seeing a theme here, and are used as input to our risk assessment codes. Then one more piece of information before I go into examples. So next slide. So we, a few years ago, conducted an important study to map out the regulatory agencies that are involved in the life cycle of hydrogen. And as you can see, the list is fairly extensive. When introducing hydrogen into a new region or use case, it may require engagement of all the regulatory agencies impacted by that use case. So each portion of the hydrogen supply infrastructure is regulated by, international, federal, state, and local entities, and regulations are enforced by entities which provide guidance and updates as necessary. And while energy sources such as natural gas are currently regulated via the Code of Federal Regulations and the US Code, there may be some ambiguity as to which regulations are applicable to hydrogen and where regulatory gaps exist. The report where this figure comes from, contains an overview of the regulations that apply to hydrogen and those that may indirectly cover hydrogen as an energy carrier participating in a sustainable zero-emission global energy system. So as part of this effort, the infrastructure of the hydrogen systems and regulation enforcement entities are defined, and this nice map and reference tables were developed. And it can be used to help identify boundaries of federal oversight for each component of hydrogen supply value chain, kind of within the system. So production, storage, distribution, and use. And this shows that, the regulatory agencies are usually those helping enforce the codes that exist and the standards that exist. So next slide. So now I'll get into some more examples now that we've seen kind of what we think about when we're trying to apply this to various parts of the hydrogen. So this is how we're influencing some of the codes and standards. This first example is hydrogen refueling station. So liquid is the preferred method for delivery of hydrogen to hydrogen refueling station simply because, it's a much more dense than compressed gas hydrogen, and so you can get more within a tank. Sandia previously worked on compressed gas hydrogen storage separation distances at refueling stations. So this is like how far away things have to be from the hydrogen components. So the tank, the storage tank, the piping, and the delivery aspects of that. And the distances would be things between the hydrogen and people, or the parked cars, or the market building. And so the gas fueling station distances were updated, and then to create consistency between both the liquid and the gas storage, we focused effort on the liquid hydrogen storage. The current the standards that exist for the separation distances were very conservative. There was a 75-foot line to the lot. There were very large, and they were just basically conservative estimates. So obviously it would be nice if we could optimize these distances, but based on scientific evidence so that we keep everyone safe. And after several years of collecting data and working with the community and the standards committee, the NFPA 2 code voted to accept the recommended updates that we worked on in the 2023 edition. So this vote happened in August. So this is a very new thing, and actually did take years of effort. For example, things like you used to not be able to use a non-flammable wall as any credit for reducing those distances between things. And so now it does things like you can include walls. and then the size, it's based more on the size and diameter of piping, so that that's an indication of how much gas can be leaked at once. And there's some things that weren't considered that are now before. And the overall result is that we can get up to a reduction of 40% in the footprint of a refueling station, which is a big deal for anybody trying to operate a refueling station. Next slide. And then this is another example. I think a lot of people are very aware of this, but in Boston, being able to drive a car is only helpful if you can go through a tunnel, because they do rely on a lot of tunnels. So they wanted to make sure their regulations and allowed for driving hydrogen light duty vehicles in tunnels. So we did a lot of work with them to understand the flow of hydrogen if it were released in the middle of a tunnel. So computational fluid dynamics of where it will go, how it will happen, what if it's all released, what if it ignites, will it have an effect on the tunnel infrastructure? And after working with them for quite a while as well, they have now changed their regulation to allow fuel cell vehicles within, I think, 3 tunnels at this point. So again, just reiterating, these changes to codes and regulations do take a long time, and really is a collaboration of effort between state agencies, regulatory committees, and the entire community. So slide 13, please. The next slide. Why am I saying? Just notice my numbering on my slides is all wrong. So now we'll move more towards end use discussion. So how have we impacted and helped with end use studies, and how in ways that we can help bring this technology to market, and how we facilitate that. We've discussed refueling station for vehicles, but the quantity of hydrogen needed for rail refueling is significantly larger, as you can imagine. The important factors when considering what the refueling station needs to do are the cost, is the time to refuel. So, any downtime is time that the trains are not operating, the cost of the infrastructure, and of course, clearly the safety of the entire system. This slide shows just one example of the assessment results for a multi-unit train using a direct fill cryo pump design. That's the technical stuff. So this report goes up with a lot of different ways to fuel, and using different components, and whether it's just a passenger or a freight type train. So the report considers a bunch of options, and this is one mechanism. So these assessments help determine the feasibility of refueling hydrogen in a manner that is consistent with their current industry needs. So if you were replacing this, that they could keep performing at the level at which they are already. Next slide, please. And then refueling is a big one in this talk, which didn't occur to me until after I had done that. But this shows a project that was, I think, started in 2016 or 17. And that is the ability to certify refueling stations. At the time that they were being rolled out, each vehicle manufacturer had to certify the refueling stations on their own, which of course is not an efficient way of doing it. And so HFTO again funded Sandia and NREL and Power Tech Labs, which is a Canadian company, to design this portable certification unit. And so this unit meets the code standards that I've listed there. And the first one actually is both ANSI and CSA. CSA is the Canadian standards, and ANSI is the American standards. But the test methods and the fueling protocols standards. So this includes things like the communication between the dispenser and the vehicle, and as well as the fill. So, if you're filling a gallon, are you getting a gallon? All of that kind of stuff. And this is currently used by California. And my understanding is they are about to build update the unit and build another one because they are still being used and in demand. So this can be just take it to the refueling station and certify that it's operating properly. Next slide, please. And I'm getting close. So now we're just going to talk a little bit about maritime, more end use. Kind of end use applications. This is one that again has been going on for a while, but we've been working collaboratively with Scripps Institute of Oceanography to help them replace one of their research vessels is at end of life, and they wanted to do to try to update it in a more green manner. So they turned to hydrogen fueled vessel. And we helped work with them on designing the layout of a hydrogen fueled system and to understand the risks associated with it. So, you know, where would the liquid hydrogen tank go? And in the fuel cell, this is run by fuel cells. So in the fuel cell room, if there's leaks, if there's issues, is the venting of the room okay? What if the venting shuts down? What are the impacts of all that? So we did a lot of studies like that for them. And then excitingly, California did fund them to produce this vessel. So now they're in the stages of, I think they picked an engineering firm, and they are in the stages of starting to try to build it out, do final designs and build it out. This is actually in combination with a diesel engine. But as this says, 75% of the missions, which are just local, going out regionally, you know, in the area, can be performed on H2 alone. I think the diesel is really for those long journeys where they need a backup for that. Next slide, please. This is an interesting project that is funded and is just kicking off, and it's to use a barge as a kind of a refueling place that, but dual purpose. So if you dock the barge and there's electricity available, the electricity could be used to produce hydrogen, and then the hydrogen can either go directly to filling a vessel, or the electricity from the dock could also just be channeled into, you know, recharging a battery electric system, or vice versa. You could have a hydrogen tank come in and provide hydrogen to the barge, and then that hydrogen could be either directly put into vessels or converted to electricity to help charge vessels. So it's kind of this all over a multi-use, multitask thing. The idea with the barge being that you know, whether or not there's real land space available, this would be a way of providing refueling ability to vessels kind of anywhere. This is a very new project, and so they're working with the Coast Guard and MARAD and local companies to put this demonstration pilot project together. And I think last slide. Yeah, so those are just some of the examples of how science can enable the use of hydrogen in the economy, and hopefully that gave a sense of the kind of science that does go behind making this a safe way to provide an energy carrier to our economy. Happy to answer any questions as long as I didn't go too long.
Kristen, thank you so much. This has been so much fun. I feel like I've learned a lot during this presentation, so thank you for coming to talk with us. We are running a couple minutes behind schedule, but it is not your fault. It is our fault for getting a slow start. So if folks are okay with it, or Kristen, if you're okay with it, I think we might propose that we either, if you have time and are able to take some questions in the chat, or if we can follow up with you via email for questions. I just want to make sure that we're giving time for our subsequent speakers. Is that okay?
Absolutely. Yeah, absolutely. I can look through the chat, and please feel free to contact me and reach out. I'm happy to, as I said, I'm not the technical expert, so I may refer you to others who could give you a better answer. So yeah. Thanks.
No, this has been really great. And I'm sure you've been presenting, so you haven't seen them, but there's a bunch of questions in the chat from the team. So thank you so much, Kristen.
Great. Thanks.
And okay, and with that, Brian, I'll go ahead and hand things back to you to give us a little bit of an introduction to our discussion with Adrian and Bridgeport.
Great. Thank you for that, Aaron. Thank you, Kristen. That was a great presentation. So yeah, folks definitely provide comments, questions in the chat, and we will work to respond and do some follow-up. As we're all delving into the science, the sources, the uses, the infrastructure, all the things that have been laid out in the Special Act, it's really important that we continue to pull ourselves back. We can get very excited by the opportunities that are presented by the hydrogen fuel cell infrastructure, but we also need to really take stock in terms of how we engage our communities. And I'm reminded of a conversation. You may know that I serve on the Secretary of Energy's advisory board, and I'm not saying anything out of turn that hasn't been said publicly. But in the conversation that we had on the clean hydrogen hubs, there was a discussion around the match, the dollar match. And the Secretary made it a point to say that she wanted to express the importance of the Justice 40 initiative to the administration. And I think we see the importance of that when we see that Justice 40 has, I think, a 20% weighting in the next proposal. So they're serious when it comes to how we engage communities in the conversations when we think about, sources, infrastructure, and uses. So with that in mind, we've got a great chat coming up. Aaron is going to moderate, which includes Adrian Ferraro. I've known Adrian for the last couple of years, and she is an extraordinary entrepreneur and definitely a community advocate at the south end of Bridgeport. And I want to turn this over to Aaron to further introduce Adrian, and let's get the conversation started on what's happening in Bridgeport.
Thank you so much, Brian. And Adrian, welcome to our Hydrogen Task Force. We are so excited to have you with us today. Maybe just to get things started, if you wouldn't mind providing a brief introduction to yourself, what you've been working on, and why environmental justice has been so important to the community of Bridgeport.
Hi, good morning, everybody. Some of you I know quite well, as a matter of fact, and have been working with you on energy issues, on zero waste issues, and a lot of issues that our Department of Environmental Protection and Energy have been working on. So is there some feedback here? I thought I heard some. Is there a way to correct that? Should
We've got it. We've got it.
Oh, cool. All right, great. So yeah, my name is Adrian Ferraro. I run a nonprofit in Bridgeport that has had a couple of different missions over the years. We're kind of an outgrowth from the community action movement across Connecticut, and especially in Fairfield County, and through what used to be ABCD and is now the Alliance for Community Empowerment. And we have had a lot of input in Bridgeport programs over the years that have looked at energy conservation and clean energy projects. We've worked in weatherization, and we've also been working in zero waste, most particularly in the recycling of mattresses and box springs, which is a Connecticut law that came out 7 years ago, and we were the first to jump in, and we employ 20 individuals in that field, and they are mostly second chance citizens. So we have a kind of broad mission. I myself have served on different state committees where I met Brian and a whole bunch of others of you. And it's been a great pleasure to work on the GC3 committee, and I'm working currently on the CJAC, which is an advisory committee to the Deep Commissioner. So that's kind of my introduction. You wanted to know more about Bridgeport and what we've been up to in Bridgeport. Well, Bridgeport has a kind of long history of looking at environmental issues. In terms of environmental justice, to focus really on that because that's the subject matter today. Because it's an old industrial site and city, Bridgeport has had a lot of leftovers from the times that industry was pretty much focused in the city and was a great source of richness for the city. But we were left with some skeletons, let's put it that way, that don't smell so good anymore. And I think the EJ community has kind of grown up around protests about the coal plant, about RESCO, about water treatment plants, about sewage treatment plants. There are 8 affecting entities in our small city. Our small city in terms of geographic coverage, because we're only 16 square miles. So that's a lot of stuff. That's on a lot of people. We're about 145,000. We are an EJ community designated by the state, and we are a disadvantaged community also designated by the state. So we have kind of a cross designation that means that we have to work pretty hard to overcome some of these obstacles and have our communities thrive. So yeah, EJ is kind of in our blood because we've suffered a lot from our industrial history that kind of fell apart, and also because of the affecting entities that are still active and the impact they have on both the health and the well-being of our communities. And people recognize that pretty well. Does that answer the question of why we're interested in EJ?
Yeah, it does very much indeed. Yes. Well, with that background, can you talk to us a little bit about the Bridgeport Regional Energy Partnership and what it means in the context of these issues that you're facing?
Okay. Well, this got started just about a year ago. It's interesting. Yeah, this is just about a year ago. The idea came about because there's kind of a groundswell about possible financing in energy projects that we thought was pretty interesting for us. And we really wanted to be part of both the national and statewide interest in what kind of energy projects would benefit our community. So we kind of pulled this together. I have to admit that I was pushed a lot by Brian. He's at some of the base of this. We also had Brenda Watson from Operation Fuel, very much interested. And we had on a local level, both the city and the regional business council, who has been very active and put a lot of resources into helping everyone pull together the Bridgeport Regional Energy Partnership. And I can talk to you about the membership. We're about 42 both organizations and people who are involved in this, and it's a bit institutional. I wouldn't call it community-based in terms of the grassroots aspect of it, but it does cover the community in terms of the educational community, the nonprofit community, obviously representation from the city and from the business community. We've covered a lot of bases and got a lot of people who are very, very interested in what our energy future can look like and what it can do for our community, both in terms of the economic development and in terms of the health outcomes for the community, and of course, the energy burden for the community. And you can shake your head yes about energy burden, because I don't think there's anybody in this room or in the state of Connecticut that doesn't know anything about energy burden, because we are all energy burden. But obviously, when you're talking about a disadvantaged community like Bridgeport, the energy burden is all the most recognizable, because the average household is I guess we're about 20%, 21% of households who are at the poverty or below the poverty line. So it's heavy. It's heavy, the energy burden. So those are some of the reasons we were very interested in pulling this group together. And we wanted to be able to answer the US DOE's call for proposals for developing an energy plan. And that was through LEAP, which is, okay, let's see about LEAP. LEAP is Local Energy action program, right? Is that right? Yes, program. And it's a pilot. And it's been awarded to the actual grant has been awarded to 24 different communities, one of which is Bridgeport. And of course, our B rep did do this this submission and got this really precious technical assistance to develop an energy plan.
And would you be comfortable talking to us a little bit more about this technical assistance plan and specifically where BREP is focusing their efforts? I'm really interested. I know there's a couple of areas around workforce development that have been coming up.
Sure. Well, the US DOE asked us to consider several different pathways. There were 7 pathways. And of course, when we had to look at it, I want to do all of that. Well, no, I can't do it all, but we kind of did come down around 3 different areas that we thought were really important for us. And that was clean energy development, renewable energy development, particularly as it concerns buildings and weatherization and building codes and all of that. And then the third area, which everybody's very excited about as well, is economic development, which means we want to develop a workforce that can really work in the supply chain for energy manufacturing. And so that is very exciting. I'm on that committee because of my excitement about it. And we have our BREP members divided up into those 3 committees. The workforce development and economic development portion of it is really interesting because it pulls together the educational committee, our workforce development board, and folks who are at the workplace here in Bridgeport. And it also pulls together the manufacturing community. And of course, anybody who is interested in economic development knows that if you can pull on your community to get folks who are interested in being trained and going through the development work that's necessary to get into these new proposed jobs, then you've got something that's really solid, and you can really invite a lot of folks who are going to be in that area into your community because you've got the ground for it and the infrastructure for it.
Right, and we know how big that's going to be, especially as we are continuing to transition our economy.
Absolutely, and can I just say one thing? I know Joel's on this call, and he did a great paper back in I guess early spring, and we've had BREP has pulled together its members to hear him talk about the hydrogen economy and this new energy. And one of the things that we learned from him is that we're going to be developing more than 6,600 jobs as we go through this hydrogen economy and build out what the manufacturing is going to look like and what the delivery system is going to be. And so where are you going to get them? Right now, anybody who's looking for workers is struggling. You've got to get close to the community so you can get them excited about folks being trained in these areas. They're going to be new. The community has to understand it, and it's going to be part of our growth here in the state of Connecticut. So it's going to be really important that a city like Bridgeport and other cities in the state really pay attention to getting folks interested in what these new developments are. So they understand it, they know that it can bring economic development, they know what some of the pros and cons are. And if they accept the pros over the cons, then they can really get the community excited about participating in this new development.
Yep. Yeah. Right. And that's a huge part of where we're trying to go with this. I know we do have a workforce development element to our work groups. So I think one thing I may ask you as we get later on in the conversation is where we see some of the gaps between where we are today on this front and where we need to be, right? Because that's a big piece of what we're trying to tackle here. But maybe to pivot a little bit, can you help folks understand the concept of community benefit agreements and why they're so important?
Sure can. to go back to LEAP and the US DOE, we are in the beginning process of doing our scope of work. And one of the things that we've been looking at are what are our objectives? What do we want to get out of this work with the technical assistance? And would you believe that very high on the list is getting a community benefits agreement done? And that's kind of going to come after we finish our scope of work and almost before we start working on the plan itself. And why is that? Because we want all of the different stakeholders in the community to sign on, because there's going to be work to be done, right? And if people don't sign on early and often, you're going to wind up with some folks who follow and some folks who don't. So the explanation of what it is, the explanation of what you're trying to do, the buy-in that you want to get from the community, the face-to-face contact that you want to have, with different neighborhood groups and with the community groups, that's got to take place I would say kind of now. We're already looking for an outreach person who can kind of get this organized. We are already working on a plan of how we're going to reach out to the community, with what tools, how often, where, and how. And so all of that is going to be able to get us, started on identifying those entities that are going to be signing on to the community benefits agreement. And that's one of the things that we really want this technical assistance to help us with, because we figure it's really, really important to get it done early in the process.
And can you talk to us a little bit about, just specifically in the context of hydrogen, where you're seeing gaps between where we should be in terms of community outreach and engagement, especially as it relates to some of the timing that we've been talking about, versus what you're seeing today kind of on the ground?
Well, I don't think anybody knows what's going on in hydrogen, okay? I count myself as being one of the fortunate people who has heard about it, who has had an opportunity to hear Dr. Reinbold about what's happening in hydrogen and what the hydrogen hub might mean, and what it is, and some of the pros and cons. But Aunt Tilly, who lives on Union Avenue, doesn't know anything about this. And so that's the challenge. And of course, it's a challenge to get people to understand what it is and how it is in layman's language, so that they understand what the benefits can be for themselves and for the community. They've got to see themselves in it somehow. So that's, I think, is the biggest gap. The gap is to get the information out. The gap is to speak the language of the community. And believe me, the community they aren't a group of dumb people. That's not what we're talking about at all. You don't have to talk like a kindergartner, but you do have to lay things out 1, 2, 3, A, B, C. And I think that's what's definitely lacking today. I laughingly have said in a couple of meetings that, okay, what the community knows about hydrogen has to do with the Hindenburg blowing up in World War II. That's about where it's at. I mean, for those of us who are old enough to remember that there was World War II. So those are some of the gaps, and I think we're kind of at ground zero. There's a lot to do.
Yes, I mean, the fact that you're saying the latest news on hydrogen comes from World War II tells us that we've got some work ahead of us. I think, Brian indicated this at the beginning of the conversation, that the Biden administration is really establishing some very strong policy imperatives and priorities around equity and environmental justice. Specifically, we're seeing that come up as a large portion of federal funding, especially for hydrogen hubs. So I guess just sort of a really expansive question for you, but really interested to hear any thoughts or recommendations about how this task force or the Northeast Regional Hub should be thinking about community engagement, environmental justice in the context of this hydrogen work. And would also love, as a part of that, if you have any recommendations about actions that this task force should be considering, and particularly considering, given that we're intended to be taking recommendations to the legislature, would just really love to hear your thoughts on sort of what are the key actions, what are the specific things that we should be thinking about if we are trying to bring communities along in this journey.
Whoa. Okay. So when we talk about getting out to the community, that's no different in Bridgeport than it is in every other part of the state of Connecticut. Talking to groups, talking to people, getting them to understand. They already know that they're energy burden. That's no secret to them, and they know that there's a lot of conversation about what can be done about that. So this is one of the paths to getting to a more comprehensive plan about attacking energy issues and about bringing these benefits to the community. So. Yeah, I think there's a lot that can be done in terms of speaking to people in their language, meeting them where they are, and if you'll permit me, I'll kind of read off some of the things that I thought about because there's a long list. Hate to bore you and tell you what how long this list is, but we need to first develop some sort of criteria for identifying community impact. This group can do a lot about that because we're going to be measuring what the impact could be on the community of bringing additional and better, hopefully, solutions to our the energy needs in our communities. We need to provide some dollars for for outreach, to talk to the community. I know I'm close to community in some respects, but I may not be the right person to talk to everybody. So there's got to be a kind of plan of who talks to the community, where, under what circumstances, and what's the message that we are going to be able to give them. There's got to be community participation in discussions. So how are we going to do that, with what? And there's got to be a plan to get that done. You got to get key agencies that are already working with the community involved. And that's really going to be important because we've got CAP agencies that are already talking to their members and their communities about energy because they're helping to finance energy. So why not get them to be vectors of communication in terms of getting the word out about what are some of the alternatives that are going to be coming down the pike. And then I served for quite some time on the Energy Efficiency Board, and there are all the actors are right there. I don't know why they can't help to be vectors of communication as well, because they have folks who are all over the state who can carry water in terms of this particular message. And then, we're in the middle of the New England. I'm sure some of the other states are doing some of the this kind of planning and outreach as well. What can we copy from some of our neighbors? And on into New York, which is also starting to look at, how they're going to talk about their communities. And I know NYSERDA is involved in these conversations about where we're going with the energy issues. So yeah, I think there's a lot that can be done. And I look forward to hearing from this group of folks how you think you can be impactful in terms of carrying this message to all of our communities across Connecticut and our partners, because we aren't alone here. All New England states are kind of listening to the same issues. So we can pull in expertise in terms of this communication from other places as well.
Yes, I'm here. So I'm just going to repeat back things I'm hearing from you, which is themes around the need to really focus on this. We're dedicating money to infrastructure development. Let's dedicate some money to community engagement around that infrastructure development. I'm hearing themes about needing to make this pervasive, right? We have a toolkit out there. We have folks who are out in the communities engaging. Why are they not engaging on this? Let's figure out how to work through systems we already have in place. I'm hearing things about not reinventing the wheel. Everyone is doing this. Let's do it together. Let's do it smart. Let's learn from our neighbors, because these are challenges that a lot of different areas are facing. And so we really need to be kind of picking up those lessons learned from other communities. So there's at least one question in the chat about community benefit agreements, but I think, and getting examples of that, but I think we'll follow up on that one offline. We're also getting
Okay.
comments in the chat that you are not boring at all. So thank you so much for joining us today. This has been just so lovely to hear, how you're thinking about these questions, what we can be doing better to engage communities. We are unfortunately running to the end of our time. I feel like we could be talking about this for hours, but I guess just wanted to give you kind of a chance to say any last items that you think folks should hear that we haven't had a chance to talk through today.
Well, I think the idea of getting together a community benefits agreement is an important one for all of us. And it's not just Bridgeport, it's, all of the communities across the state of Connecticut that need to be involved. We need to learn from each other, and sometimes we're a bit insular. So since this particular group is probably representing a lot of different areas in the state, I would hope that you can come back and talk to us about how you think some of the very technical things that you're talking about can be translated to the communities that need to be engaged. And I would really welcome that, because we know what we know from our daily exercise, but we don't know what we don't know from what's going on in other parts of our economy. And this is a very important economic discussion.
Yeah, yeah. I know, and we're all, we spend a lot of time on this, and, getting Kristen in this morning to talk about topics like safety and what it looks like to site infrastructure in communities. We are all still learning. And so I think your point about needing to make sure that as we continue to learn as a group, we're going back to communities, sharing that information, again, making sure they're part of the journey is certainly a point well taken.
Excellent. Glad to meet you all.
Well, thank you so much, Adrienne. This has been so lovely. I don't know if folks have additional questions that they want to put in the chat. And Adrienne, if you're willing to kind of hang out with us and answer any of those. I know, Kristen, thank you so much for getting back to folks. I know there's so much stuff to talk about today. It's you never think that a 2-hour meeting is too short. But thank you so much, Adrienne. We really appreciate your time.
Thank you for your invitation. Appreciate meeting you all.
Okay. Well, with this, I think this has been a great chance to get a little bit more of a sense about some of the key considerations that we want to be bringing into some of our working groups, and a great chance to turn to some of our working group updates. So just as a reminder, if we can move to the next slide, we are working through 5 different working groups. Our working groups kicked off in September, but we are excited to continue to drive a lot of this research around questions like safety, workforce development, infrastructure through this work group process. So just as a reminder to folks, on the next slide, we have an overview of the schedule that we'll be running through the end of the year. So as I mentioned, we've already kicked off in September, but if you missed that one, no worries. We are going to continue to have some really great discussions through October, November, and December. So please do come and join us. All of the information on these public working groups is on the Green Bank website that Brian referenced at the beginning of this call. And so we would be happy to get anyone who's interested involved in this working group process. Next slide, please. So one thing, we're going to be giving a little bit of a flavor of what these working groups are covering. But before we do that, I just want to give folks a sense of, how we're expecting to see this working group effort, which is really, I think, the heart of some of the content that we're trying to dig through, and how we're going to be seeing that flowing back into the final report. So when we're starting to sketch out that report and at a high level what we're expecting it to cover, you'll see on the left side of the slide here the 5 different sections that we are planning to cover. And I want to provide a little bit of insight specifically on the findings and the recommendations that we're planning to dig into. So findings specifically, we'll be talking about the research and analytical findings that our working groups are digging through. We'll also be covering stakeholder feedback and areas of consensus and where there may be disagreement and majority and minority views, which is part of why we are very excited about getting folks to join into these working group conversations, because stakeholder feedback, because this input is so important to our understanding of these issues. We really want to make sure that this is showing up and that we're able to capture this and carry it into the report. Now, when we talk about how these findings get carried forward, we are planning to lay out a set of recommendations. So I'm not going to read out the full list of topics that our recommendations are expected to cover, but you can see them on the slide here. Our main goal really is to be identifying potential actions. So when Adrian comes in and says, hey, we really need to be thinking substantially about community engagement, and it would mean a lot if there were some dedicated funding to enable dedicated community engagement and outreach. Those are the types of actions that we would be contemplating for inclusion in this report. So I just wanted to give folks a sense of where these working group efforts are going and how they'll be carried forward. I'm going to take a brief pause for questions in case anyone has them before I turn things over to some of our work group leads. Okay.
This is Barbara. Under incentives, what does this consist of? What kind of incentives?
Yes, so one of the topics that will be covered by the funding work group is exploring what types of incentives may be appropriate. And we are expecting that effort, looking at incentives, to be informed by both best practices that have been adopted in other jurisdictions, as well as the specific opportunities in Connecticut, which we'll be digging into through the uses and sources process. So a lot of these recommendations will really be a blended integration of different streams that are happening in different work groups. So again, this is how we're kind of bringing these things all together into kind of a seamless whole. I hope that helped to answer the question, but please let me know if not.
So it's both, so is basically financial incentives that you think is going to go under that umbrella?
So we'll be looking at a variety of different incentives. Actually, the next funding work group will be walking through some of the best practices that we've seen in terms of incentives that have been established for hydrogen production, for hydrogen use and offtake, for supporting some of the enabling infrastructure. And I think we're kind of trying to look comprehensively across that set of topics.
Thank you.
Of course. Okay, well, keeping an eye on time, unless there's any other questions, I am going to turn things over to Joe to talk a little bit about the policy guiding principles that have been laid out as part of the first policy and workforce development work group.
Yeah, thanks so much, Erin. So as we shared during the last task force meeting in September, one of the first deliverables from the policy and workforce development working group is a set of what we're calling policy guiding principles, which we presented at our first working group meeting on September 26th. And so I wanted to just take a moment to give a little background into what we're intending from this set of principles. Of course, with the task force and the working groups, as Erin just talked about, sets of recommendations will be coming out of this process, including potential policy actions. So policy is really a thread through all of this. And so we want to ensure that recommendations are in alignment with the intent or the trajectory of existing policies or proceedings. So really what we're putting forth here is, it's a set of guardrails. There's 5 different working groups, and obviously we're operating in collaboration, but there's also independent work. So we want to make sure that none of the recommendations coming out of the working group process are infeasible from a policy standpoint or contradictory to existing policy or trajectory in Connecticut. The objective is really to clarify for all working group chairs, task force members, and other participants how they can focus their recommendations to ensure alignment. And part of that is to indicate areas of state policy or law that should be incorporated into the planning process, or areas that are known to need update or additional assessment to appropriately address hydrogen-related opportunities, as well as areas where additional stakeholder engagement, record building, or consensus will be necessary. And just to step back, a reminder here that the task force and the working groups aren't intending to replace the stakeholder process that's used to develop and vet updates to state policy. Really what we're working towards here is bringing forth ideas for consideration and recommendations on how to incorporate hydrogen into a clean energy economy. The other piece here is just ensuring that we are transparent throughout this process, and as we continue making sure that an environment is created to maintain that transparency. So with that context in mind, we can walk through the 5 policy principles that we proposed on the next slide. And so, as I mentioned, these are guardrails, but they're also filters to make sure that throughout this process, we're identifying appropriate policies or regulations that either need to be changed or instated to achieve any of the goals established by the other working groups. And so, the first principle is just ensure that recommendations are in compliance with relevant state policies that already exist. And if there is a recommendation from another working group that would be non-compliant, then any necessary changes would need to be identified. The idea is to sort of take a holistic look at existing policies and also potentially weigh the pros and cons of any changes that would need to occur. Of course, this would also mean we need to align with any active state policy or regulatory proceedings, including things occurring at DEEP, PURA, or elsewhere, and making sure that recommendations are in alignment with and coexisting with other concurrent initiatives or goals from the state. So this will also include identifying any fundamental underlying challenges or potential enablers. And, that fits along with what we've already said about, taking a holistic inventory and understanding what might help or hinder any recommended actions. The next principle is identifying expected impacts to any active policy proceedings. So again, if we do make a recommendation, what will be the impacts on those proceedings? And finally, recommendations will need to identify relevant stakeholder proceedings that could be used for additional public review and input and community engagement to make sure that we are getting that perspective. And so as a backdrop to all of this, next slide, and really in line with our first principle of consistency with existing policies or trajectory, we want to share this is just a few examples of areas where working group recommendations will need to be aligned with existing policy. And there's also probably some opportunities here as state policy in general does support the development of clean hydrogen. The first thing to mention here is requirement for 100% of electricity supplied to customers in the state will need to be zero emissions by 2040. That's obviously a big one to keep in mind throughout this process. And then also broader goals of reductions in greenhouse gas emissions of 45% below 2001 levels by 2030 and 80% below by 2050. These are policies that should be creating guardrails in terms of the recommendations that are made from other working groups. The idea is if you're making a recommendation, here are the types of policies you have to operate by in following our guiding principles. Relating back to the power sector, just keeping in mind the state's renewable portfolio standards. That does include fuel cells, which meet the definition of a Class 1 renewable resource in Connecticut. Also ozone compliance policies, limits for emissions of nitrogen oxides from fuel burning equipment. And then of course, state policy goals for 30% of medium and heavy duty vehicle sales to be zero emissions vehicles by 2030, and 100% of sales by 2050 need to be zero emissions vehicles. Again, these are just examples of the types of policies that should be guiding our work here. As our policy working group continues its efforts, we're working to develop a fully comprehensive list of baseline policies in Connecticut relevant to hydrogen, which we will be discussing in our next working group meeting later this month. That's on October 20th. And many of those policies can also be enablers. So a good example would be the Shared Clean Energy Facilities Program for community type projects. That can include fuel cells. It doesn't have to just be community solar. We're working towards a strong set of best practices as well, and that will be informed partially by policies proposed or enacted elsewhere in other jurisdictions. And I think we can go to the next slide. As we presented the guiding principles at our first working group meeting, we did ask stakeholders to identify any potential gaps in what we've developed so far. Do the principles achieve the objectives that I laid out on the first slide here? Are there any policy guiding principles that would be particularly applicable to other working groups specifically? And as I just mentioned on the previous slide, we asked for input on which state policies are most relevant for hydrogen and should be kept in mind to help guide the work we're all doing here. We got some very good input from working group participants and stakeholders, which that did help inform the previous slide here. But with that, I do want to open it up a little bit to any stakeholder feedback on anything I've just covered relating to our guiding principles and our work so far. Okay, in the interest of time, we'll move forward a bit, but if you do have questions, please drop them in the chat or always get a hold of us. But with that, I'll hand it off to Colin Smith now to provide an update on the uses working group. And thanks so much for your time.
Thanks, Joe. So I'm Colin Smith, Senior Consultant at Strategy, managing the uses, sources, and infrastructure working groups, all of which are very interconnected. And I wanted to talk to you a little bit today about some of the recent updates coming out of the uses working group specifically, which is tasked with evaluating the potential demand for hydrogen from end uses within the state of Connecticut. Now, one of the reasons why hydrogen is such a powerful solution for decarbonization is because it can be applied in a number of different sectors and applications. But that versatility also creates a challenge because not all end uses are created equal. In some cases, application where hydrogen could be used, there might be a more cost-effective alternative to decarbonize that end use. There may be other ancillary considerations that would make hydrogen a better or worse fit for that particular application. And so it's important before starting to assess the effective demand for hydrogen in the States, we look at which end uses in hydrogen should actually be priority uses for the fuel in the future. So the plan is to evaluate these 12 end use categories you see in front of you to determine which one should be priority applications for hydrogen, and then build the demand assessment on top of that. I'll note quickly that some of these end uses may not use hydrogen directly as a fuel, but may use a fuel derived from hydrogen, such as green ammonia. In which case, we would still consider that to be an end use for hydrogen because that particular fuel would still increase demand for hydrogen in the state. Jumping to the next slide, I'll go into a bit more detail about some of the way we're going to be developing this prioritization. So we've developed a framework with 8 evaluation criteria that will be assessing each of the original 12 end uses on. These include the cost effectiveness of a hydrogen technology compared to the most likely decarbonization alternative, comparing the direct life cycle cost of a particular technology to the most likely alternative way to decarbonize that end use. Greenhouse gas reduction potential refers to the opportunity to reduce in-state greenhouse gas emissions by switching a particular end use to hydrogen. So making sure we're focused on the applications and sectors that contribute the most to Connecticut's greenhouse gas emissions. Technological maturity and commercial readiness refers to the speed at which a hydrogen-based technology could be commercially deployed, with technologies that could be deployed more quickly being prioritized because they can help build a market for this fuel. Infrastructure requirements refer to the need for ancillary infrastructure to enable hydrogen use in a particular sector beyond the initial cost of the hydrogen technology itself. The environmental justice criterion looks at the pollution impact that fuel switching to hydrogen would have on disadvantaged and frontline communities. Similarly, the workforce development criterion looks at the impact that hydrogen technology would have on local employment opportunities. Both very interconnected criteria, both very important to the overall evaluation. Resilience benefits refers to the value of improving a particular end use's resilience to inclement events like storms, fuel shortages, or supply risk. End uses where resilience is a more important element would score higher on this particular ranking. Finally, we'll be looking at safety regulations, specifically the extent to which the deployment of hydrogen for a particular end use would require the development of additional safety protocols above and beyond what currently exists. So this criterion will be utilizing a 3-part scale to evaluate each end use, which will receive a low score, a medium score, and a high score to aid easy comparison across all end uses. This could be in the form of a 1, 2, 3 ranking, with 1 being the lowest ranking end use could achieve on a particular criterion, and 3 being the highest. So we have information on more detail on each of these criteria in the appendix, and I'm happy to go into more detail on any in follow-up questions, but there's 2 in particular that I wanted to discuss in more detail. The first being the cost effectiveness criterion, which will be incorporated as a gating criteria in the evaluation process. Basically, if an end use does not score above a 1, above the lowest score in this particular criterion, then it will be excluded from future analysis. It will not be looked at as a priority application, regardless of how it scores in other criteria. This is because a number of the other criteria that we're looking at aren't particularly relevant if there ends up being a more cost-effective way to decarbonize a particular end use. For example, it doesn't necessarily matter the greenhouse gas emission profile of a particular sector if there's a more cost-effective way to decarbonize that sector than hydrogen. If that's the case, then you can still get those greenhouse gas emission reductions using a different technology more cost-effectively than if you're using hydrogen. And so it doesn't make sense to continue evaluating that particular end use across the other criteria. So given the importance of this particular criterion, we'll be looking very closely at evaluating each end use through a literature review, looking at both head-to-head comparisons between hydrogen technologies and the most likely alternative decarbonization technology, which in most cases will be electrification. And then we'll also look at system-level modeling that identify the most cost-effective uses for hydrogen in advancing national decarbonization, which will allow us to develop a systems-level view of where the best applications and most cost-effective applications are for hydrogen across the entire U.S. economy. Going on to the next slide, I also wanted to dig deeper into the environmental justice criteria, which is another very important criterion, as we've heard throughout this presentation. Engaging local communities and making sure that we're providing benefits for local communities is going to be a key consideration for Connecticut going forward. And this particular criteria has a substantial geographic component to it that I wanted to talk about a bit more. Specifically, we're looking at the impact that fuel switching for a particular end use would have on disadvantaged and frontline communities around the particular user. And so we have information on the locations of environmental justice communities, distressed municipalities, federally recognized tribal lands, as well as geographic information on the locations of different potential users of hydrogen. You can see here a couple of potential users in power plants, port operations, industrial users. And so as we're evaluating whether or not it makes sense to switch a particular end use to hydrogen, we'll be looking specifically at the impact that end use, fuel switching for that end use would have on the communities immediately surrounding it. So from this map, you can see that if we were to, for example, examine switching gas power plants to run on hydrogen instead, we can very clearly see the exact communities that fuel switching would impact. And so this is how we'll be evaluating this is how the environmental justice criterion will be developed and assessed as part of this analysis. So I'll pause there. Happy to go into questions if we have time on these or any other criteria that discussed as part of this presentation. but I'll pass it off to Aaron to also move forward if we're short on our time here.
Yeah, if folks have any questions, please chime in here. I just want to make a brief note, thank you, first of all, thank you both Joe and Colin for joining us and speaking through these issues today. Our goal with this task force is to continue to highlight some of these topics that have impact across our working groups or on topics that we see as being very core to the overall objectives of the task force. And so we will continue to be bringing these forth to the task force so folks can have some visibility across the efforts that are going on in our work groups. And so we do welcome any questions that folks have right now, but if not, I will turn things over to Brian to close us out with public comment. Okay, hearing none, Brian, I think the floor is yours. I think the phone in the room may be muted if you were speaking, Brian.
Brian is speaking, Aaron.
Okay. How's that? Yeah, well,
We can hear you.
all right. So no comments?
We are getting a bit of an echo, Brian. If other folks in the room could mute themselves.
All right. I think that does it. All right. So we're at the public comment portion of the agenda. I'm just going to pause here. If anyone has any comments, task force member, working group member of the public that wants to provide any comments, feel free. I'll just pause for a minute here. Just raise your hand. Yeah, we can leave this. I'll just use this. Aaron, if you see any hands raised, just let me know. There we go. All right, I see a question from Lily. Or comment, please.
Yes, I have a comment, but if there are questions related to the content we just saw, I'm happy to let those go first. All right, well then I will just dive in. Let me just share my camera really quickly. Can folks see me? Okay. Hi, everybody. For those who haven't had the pleasure of meeting, my name is Lily, and I am a project manager at Strategen. I've been supporting the task force with the funding working group. But separately, there's another big project we've been working on that's a hydrogen event that I wanted to make sure that folks were aware of, just in light of all the educational gaps we've been talking about and the appetite for deeper knowledge and education around hydrogen. So for this event, Strategen's teaming up with the Green Hydrogen Coalition, which is a 501c3 educational nonprofit that's focused on accelerating the green hydrogen economy at scale. And our panels kind of dig into the cutting edge of the industry and a bunch of different global trends like green ammonia, different types of transport and storage technologies like salt domes, backup power sources, all these different exciting ways that, or fugitive hydrogen is another topic we'll be covering on the environmental side. So very excited for this event and the conversation, but it also will really be the ethos of the seeing is believing that we've been talking about today. We're going to be taking a tour of one of the second largest port operators and terminal operators in the Port of Los Angeles, which has some exciting Toyota fuel cell equipment, I believe some top handlers in motion, just to see the scale that green hydrogen could really accomplish. And also we were connected, interestingly enough, with the fuel cell energy team, which I know has some really exciting equipment in the Port of Long Beach. So I believe it's being tested this year during the event, but next year we're hoping to take a look at it. But building on what Adrian said, there's a ton of need for education around green hydrogen and accessibility. So as such, the Green Hydrogen Coalition, who we're partnering with, has fundraised in order to enable some scholarship for environmental justice, tribal, and labor organizations to attend at no cost. So please feel free to reach out if you have a recommendation for somebody who could make it to Long Beach and would be interested in learning. Thanks, everyone.
Excellent. Thank you, Lily. Thank you for that exciting event update and the support there for some attendees. Any other comments?
We do have one other hand raised from Samantha.
Hey, thanks, Erin and Brian, and all for the great content and presentations today. I did want to, since our last meeting, we had all the working groups, and I know everyone's not necessarily attending all of them, but wanted to share some news related, I think, directly to the slides that Colin was sharing earlier with the power plants as possible end uses. In New York, the New York Power Authority's Brentwood Power Station in Long Island was testing blending hydrogen in with fossil gas and released a report mid-month that showed that NOx emissions steadily increased as hydrogen increased into the blend, with raising NOx emission rates by as much as 24%. So it's one of these cautionary notes. I know you're compiling all the research, but just wanted other members of the group who maybe are not necessarily part of that working group to be aware of that information.
Great. Thank you for that, Sam. If we don't have a copy of that, Erin, let's get a copy and we can put it in the public comments or whatever is most suitable for folks to see. Thank you. Other comments? Okay, so yeah, I just want to kind of wrap up here and thank everyone for their continued engagement. You know, now it's going to go back to the working groups. We've got a lot of activity scheduled for the working groups this month, including specifically around workforce development. You know, that meeting is coming up on October 20th. I want to highlight Keith Brothers, who was on with us a little bit earlier, and Aziz Dekhan, who we're hoping to get actively engaged in the workforce development conversations. Keith is with AFL-CIO and Aziz is with the Connecticut Roundtable on Climate and Jobs. So our hope is to get them engaged on workforce. We've got our task force meetings scheduled for next month, looking to come back. Thank you to Wheezy and the Dominion team for hosting us at Millstone. So there will be some follow-up details there. Again, for those who want to RSVP, send us those RSVPs. Yeah, I think that'll do it. Unless Erin, you have any parting thoughts?
Just wanted to thank all of our speakers today for joining us. I think you've added a lot of richness to our conversation, and we really appreciate you making the time to be a part of this discussion.
Excellent. Ditto, ditto, ditto. All right, everyone. Thank you, and everyone have a good rest of the week. Take care.
Enjoy the tour.